You ask your AI a question, it gives you a hallucination, or it returns nothing at all. Your system is failing because it's trying to read a 300-page manual through a straw that only fits 25 pages. The fix isn't a smarter brain. Everyone wants a bigger language model, but a smarter brain can't fix a bad map. The fix is the embedding model. That's the embedding model. It's the engine that turns your text into meaning so your AI can actually find the right answer. First, vector maps. Second, the 32,000 token window. Third, the domain benchmark test. If you're building with AI, picking the wrong model means your tool is useless. You probably think embedding is just a boring pre-processing step. You picture it turning words into magic numbers. You assume any model works. That assumption is exactly why your system hits the wall. Embedding is the strategic brain. Treat it like a commodity, and your AI breaks. Think of the embedding model as a universal translator for meaning. It converts every sentence into a coordinate on a map, where similar ideas sit close together. Different ideas sit far apart. Distance equals similarity. This is how your AI understands context without reading every word. Vector maps. When you input text, the model generates a vector. That vector places your content in a multi-dimensional space. Imagine a map where the axes aren't north and south. The axes are features. One dimension is tone. Another is technical jargon. Another is entity type. Your model clusters similar concepts together. This allows semantic search. You don't match keywords. You match meaning. The distance between vectors tells you how related two documents are. This geometric structure is the foundation of retrieval. But early maps had limits. They missed the nuance. They treated bank the same whether it was a river or a wallet. Good models now separate those nuances. They understand context. They place bank near river in one coordinate and near money in another. This is structural understanding. It's not keyword matching, it's geometry. And that brings us to the size trap. In a second, I'll show you the jump that breaks the old rules. The 32,000 token window. Old models capped out at 892 tokens. That's about 15 pages of text. If your document was longer, the model had to chop it into tiny pieces. This caused fragmentation. You'd retrieve a piece that made sense alone but lost the thread of the whole. You got partial answers. The new models scale to 32,000 tokens. That's 60 pages. Enough for a technical manual, enough for a legal contract. This solves the fragmentation problem. You can now match the whole idea at once. Retrieval accuracy jumps. Benchmarks show improvements around 7%. That sounds small. But in retrieval, 7% is the difference between a helpful assistant and a broken tool. You get coherent answers. You stop getting partial nonsense. But there's a catch. Bigger windows cost more. Processing larger vectors increases latency. You're moving more data. The model has to work harder. And maintaining coherence over long stretches requires optimization. The model can drift. When the window gets huge, the model can get distracted by the middle of the document and forget the start. This is called the lost in the middle problem. The new models are better at it, but you still have to watch for it. Size helps, but size alone isn't the solution. You need to manage that window carefully. And that's not even the weirdest part. Size creates a new trap. Stick around for the one metric that saves you from wasting weeks. The domain benchmark test. The biggest mistake isn't the size, it's the fit. A model trained on code excels at technical docs. It understands functions and logic. It knows what a class is, but it will fail on creative writing. It misses the tone. It misses the nuance. It treats a poem like a spreadsheet. You must pick the model that matches your content. This requires the domain benchmark test. Generic benchmarks lie. Public leaderboards are marketing. They test on data you don't have. You need to test against your own data. Take a sample of your actual documents. Run your queries. Measure the accuracy. If the model retrieves the right answer for your specific use case, you keep it. If it fails, you swap it. This is the only way to know. Your retrieval wall is unique. Your benchmark is your insurance policy. Also, remember chunking. Chunking prepares the data. Embedding transforms it. They are coupled. Chunks that are too small lose context. You split a sentence in half and the meaning dies. Chunks that are too large dilute the signal. You drown the relevant part in noise. Smart chunking isn't just about size, it's about structure. You want chunks that represent complete thoughts. You want to avoid cutting in the middle of a paragraph. Use semantic chunking tools that find natural breaks. This works hand in hand with the embedding model. The model needs clean input to create clean vectors. Pair your smart chunking with the right model. That's the winning formula. Let's recap. Vector maps turn text into coordinates where distance equals meaning. The 32,000 token window solves fragmentation by holding large documents intact, though it costs latency. And the domain benchmark test forces you to validate the model against your own data, not public scores. Your embedding model is the lens your AI uses to see the world. Choose the lens that matches your reality, or the picture will always be blurry. Stop treating embedding as a commodity. Treat it as the strategic engine of your AI. If you want these AI concepts explained without the hype, subscribe. That's what we do here, daily. That's the full picture. If this made it click, tap subscribe. There's a new AI explainer here every day, and tap the video on screen to keep going. See you in the next one.